Hello again, everyone. We're here again with DanDoesData, usual weekly stream, and we're still playing with skflow. This week, however, we are going to be looking at the CIFAR10 image classification problem. You may have recalled last several weeks, months really, we've been playing with the MNIST digit classification, which is really classifying an image of a digit. With CIFAR, these are actual color images, and you're trying to classify them into 10 broad different groups. And by 10 broad different groups, we're going to go here and look in the Google page. Things like an airplane, a car, a bird, a cat, a deer, a dog, a frog, a horse, a ship, and a truck. So those are the 10 categories of things. So they're wildly different. There's colors. The images are a little bigger. They're 32 by 32. But this is still considered a toy problem of sorts. These things are different enough, but have some similarities. So it should be interesting what we pull out. So with TensorFlow proper, they have a tutorial, and they sort of walk you through this. Although they don't actually show a lot of the code right here, you can look at the code on their GitHub page and poke around with that, of course. But we're going to be using skflow. Since we built a convolutional model for MNIST last week, it really shouldn't be all that different. We'll add an extra 2 channels for all 3 colors, and we'll have to keep track of all that in our convolution, but it shouldn't be too bad. So I'm hopeful that this will go reasonably well. The data set's a little bit larger, but it should be all right. I've pre-downloaded the data just now because it's about 170 megabytes, so I wanted to make sure to have that on hand. Doesn't take too long, but it's still a good thing to have. And I've set up just a little bit here. Of course, we're importing TensorFlow. This is to easily download the data. TensorFlow is sort of built in with this model. This is scikit-learn. We're going to use just to get some good metrics on how we're doing. This is, of course, skflow, which will let us build simple models. Or simply build models, I should say. And these are just some flags about how I'm downloading the data and how I'm going to use it. This really isn't a big deal. We want to actually use this data, though. So the question is, where does this data live now? So I did this download business. CIFAR10.train. That's a function. Oh, that's train. I don't want to train the model. I was hoping for that'd be the training data. CIFAR10.data URL.gfile? Where's gfile? Gfile not defined. Interesting. I thought gfile was defined because you downloaded the data. Oh, maybe I didn't. So I'm following this silliness. What's gfile supposed to be? Gfile. Here we go. TensorFlow.python.platform import gfile. We're going to see what that does. Probably for loading a gzipped file. Switch between depending on pyglib.gfile or an OSS replacement. Interesting. Flags not defined. Really? Did I not? Oh, flags equals tf. You know, one of these days. One of these days I will actually see all the code I need the first time. Oh well. There we go. Okay, this is again just to get our data set ready. Didn't like that. You know what? I don't need the log. I don't care about that. Max steps, conflicting option string, max steps. Tell you what, let's just nuke that. That's quite alright. Just start that again. There we go. We've already downloaded, so we don't have to download again. Okay. Gfile. Okay, fantastic. I just want to see, how do I properly load in my data? Distorted inputs is what they're using. So they are using a distorted version of the inputs. So they're taking their original images, whatever these are, And they're flipping them left to right, so a deer one direction can be a deer the other direction. And I think they're fiddling with the contrast and maybe some other parameter. Let's see if we can do this, and this takes forever or not. Filling queue with 20,000 CIFAR images before starting to train. This will take a few minutes. Fantastic. What does that actually do? CIFAR10 inputs? That would have been the fast thing to do. Images. 4D tensor batch size, image size 3. Whereas CIFAR10 distorted inputs construct distorted input for CIFAR. What's images 0? What's images 0 when I spell it correctly? Must have rank 1. Interesting. I wasn't expecting that to, oh, this doesn't actually, hang on. Does that actually contain the real things? It looks like it does. Interesting. Images dot get shape. Get shape. So that's a tensor. Images dot eval. Is that what I want? Oh, do I need my session before I do this? I might need that. Because here they're building a graph first. So let's try that. Sesh equals tf.interactive session. Session. Like that? Really? Oh, that's a, so I'm looking at the MNIST example that I did last week, where I actually pushed a merge request or pull request to GitHub for skflow, so you can actually see how to get the weights now. If you search how to get skflow weights, you can find this, and we're going to be using that tonight. tf.interactive session. Yes, I don't know why I didn't have that. Only 4 threads, really? That's interesting. Thought I'd be getting more. Oh well, it is what it is. Let me redo this. Images.getShape. Alright, images.graph. Images.name. Shuffle batch 1. Alright, sure. Images.eval. Oh, that's probably not something I want to do. Hopefully I don't crash my machine and crash the stream. Should not have evaluated all of the images there. That was probably a mistake. CIFAR10 train. Interesting. Nothing in there, of course. In the data, we've got our stuff there. CIFAR10 batches bin. So there's our batches. Alright, well. I want to kill this pain. That's quite alright. That's what happens when you do things live. Danger. But we can just rebuild this. It's not too bad. That doesn't exist anymore. One more time. See if this works. There we go. I do have a trainer. We're gonna delete that. Do that. There we go. Okay, we are back. Images 0 is not a thing I can actually do. Images.eval is dangerous. One of those things where you just want to look at an image and see what happens. This shouldn't be rocket science. I should just wonder what are labels. These already one hot? No, yes, no, maybe. There shouldn't be 128. Oh, it's a thing that's 128 long because the batch size is 128. So those are not one hot, it doesn't look like, but maybe it does the right thing. Again, I'm looking at their code. I'm looking at 0.6 because that's the TensorFlow I have installed. 0.7 is improving. I think 0.7.1 is out, and that was supposed to help deal with the problem I was having a couple weeks ago. You can actually look that up, that issue up here. Interpreter crashes with SigSev with Python 3.5 and 0.7. So I might fiddle with that later. Reading the data should not be this complicated. And I should have like an actual numpy variable, I feel. For step in X range. Where do they actually compute something here? Sesh.run summary op. But where's their feed dict? Where do they feed in the data? That's what I want to know. And it's like they don't yet. This is just train. Am I missing something here? Distorted inputs, data dir, inputs, inference. Oh, is inference doing something funky? It might be. Pool, it's slightly misspelling, I think, or pool L, normal. Okay, not misspelled, my fault. So this is the actual model they're building. We'll be doing something similar, but hopefully a little less complicated. I mean, that's great. That's a great place to build a model. Where do you load in the data? Read CIFAR10. And why? Did I miss something here? Obviously. Model inputs. That I've looked at before. Images are cropped to 2424. Interesting. Model prediction, model training. Like, this is a good, like, what we did to do something well. But this doesn't teach me how to use TensorFlow, which is a little annoying. It just shows, hey, we can do this. Look at how good our thing is. Evaluating a model, yeah, that's cute. Maybe evaluating is what I want. Training a model using multiple GPUs, yeah, that's good too. Congratulations. Well, that's wonderful. The input data. Maybe. What's over here? What are the options? That's really the question. What are the options? This, and the other thing. Already got that open. Input. Got this open twice. Now. This shouldn't be that hard. Criminy. I did not intend for this stream to be mostly me like paging through the CIFAR data. We're a quarter of the way through this and I've gotten nowhere. That is incredibly frustrating, that reading the data is this. It's like I have the data already. Alright, hang on, maybe we're getting somewhere. Resized image, wrote queue, good gravy. Create a queue that produces the file names to read. But I believe I've already done that because I've got this images object. CIFAR10 dot inputs. Distorted inputs. Distorted image, tf.random.random. Brightness, sure. Does this just create new files? Is that it? Generate a batch of images and labels by building up a queue of examples. Okay. It just like there needs to be a feed dict in this damn place to actually train the model. Or at least something like a dictionary, but there's not. This is what is concerning me. Where do they actually train the model? Is it in train? Because it didn't seem like it was. Get images. It says get images, but that just returns like an empty tensor object. Labels.eval maybe? Just show me the first one. Watch, this is also going to crash my my terminal. All right, well maybe, how can I make an image like this? Do you have a thing to do that? Just want to look at one of the images to make sure I have the right thing. Builds the 10 model, reads the native model, reads in the native CIFAR10 binary format. I mean, that's what it says, buddy. Model inputs. Reading data to learn more about how the reader class works. Interesting. Please see the images page for a list of available distortions. To prevent these operations slowing down training, we run them inside 16 separate threads, which continuously fill a TensorFlow queue. Distance distorting them. Yeah, that's cute. I did want to get this involved into reading the data. So, I might just cancel this whole video. Who knows? Might not post it. Detailed instructions on how to get started are available at, well, there's a certain level of deepness here. And a certain level of obfuscation going on. This is building? No. Not what I want. Like, I want a numpy array of some images. That's what I want to look at, so I can make sure I've got the right thing, so they're in the right place. Because look at the data. That's the first rule of data science. And it's like they're here, but it's like they're not. Uint image 8, depth major, convert from this to that, convert from this to that. CIFAR10 record, read CIFAR10 of the file name Q. Trainer, train. It says train for a number of steps, but it's doing some stuff here. Presumably this is the actual neural net that's being created in Inference. They've already pre-computed their loss function. And then they just say self.run, self.config, initialize the variables, build summary operation, that's fine. Start queue runners. Maybe that's something I'm not familiar with. Sys.run, train up, and loss. No, this is the start time, hang on. This is sesh.run though. What the heck is train up? That's not what I wanted. Train up equals CIFAR10.train. Yeah, that's the training operation, yeah. It's like normally you put the data in. That's what TensorFlow is all about. You can put the data in a particular place that you want. Summary up, add summary, yeah, that's great. But like, I don't see where the data goes into your training op. And if I'm an idiot, that's fine. That happens. And I can't actually look at the data, which is frustrating. So let's make another one. Ah, come on. Slimeworks ripple configure. Yeah, there we go. So this is just the risk of using this strange thing. What about CIFAR10 inputs, maybe? Absolute import? What does that do for me? Tell me what it does. That's not what telling me information. Inputs? Does that give me what I want? Is it crazy to want to ask for numpy arrays? I guess we're going to be reading data a little bit at a time. But it'd be good to see how that would be done. Subtract off the mean and divide by variance of the pixels. Yeah, no, this is all great stuff. this just doesn't actually return anything proper. What does it know what to do? Alright, so you know what? We're gonna press on and suppose that it's doing the correct thing, which is a dangerous, dangerous place to be. Okay. So yeah, back at MNIST, you could just read the data, and you could actually get what that data is. And that was a good place to be, you know? So let's make a simple linear classifier, which is like logistic regression. We do, in fact, have 10 classes. Got some batch size. We got this. I suppose my classifier.fit is going to work on images and labels, even though those don't look like things I can use, but that's fine. Alright, so that's skflow. Let's see what happens. Setting an array element with a sequence. Yeah, that doesn't surprise me that that didn't work. Because these images are the actual images in the MNIST set, not whatever stuff they're classifier.fit. What are my options here? Given provided model function in trading data x and y. X, a matrix or tensor of shape, and samples, and features. Yeah, which is not images. Images is very clearly a batch of particular guys, which is great. That's dandy. I just want the actual data. So like I might just have to read it myself, which is kind of a pain. I was hoping to not have to do that, just be able to get my own data there as I wanted. And this gives you back this generate image and label batch thing. Construct an input for CIFAR evaluation using the reader ops. Read input, CIFAR10 underscore input. What is CIFAR10 underscore input? What's this? What's this? File name Q /temp /CIFAR10 data. CIFAR10 batches bin. I mean, there's a couple batches right there. Is that, you know what if we look at the readme there? Nope, that doesn't have anything. That's just a fake file. So let's open it up here. Version, hey, MATLAB version, that's great. Python version. Python MATLAB versions, unpickle. You can just unpickle it. That would make sense. 10,000 by 3072 numpy arrays. Yeah, that'd be like, that's really what you want. Oh geez, well that's what a mess. Why are they pickled? Why don't you just use numpy. Save them as numpy pure? Alright, so what version did I end up downloading then? That is the real question. What version are these guys? Can we read in the datasets? That is the question. Simple things that should not be complicated. Is there a pure binary version? There is a pure binary version. That might really be what we want. Just pure binary, read it in as straight numpy, and just get all the things. Don't care. Like 100 some megabytes, we can handle that. Are they color images, 10 classes, nothing too fancy. 80 million tiny images, that's cute. what does this look like? Data batch 1. Yeah, sure, that's fine. That's not what I wanted to do. Head. Okay, that's not obvious. What's going on? CIFAR10.input.read. Yeah, how do I get my hands on CIFAR10 underscore? Is there a read? Print function, sys, inputs. Oh, that's CIFAR10 inputs. Dots. Read CIFAR10. And that's to read a particular file. File name Q. Queue of strings with the file names to read from. Jesus. An object representing a single example with the following. Why don't you just give me everything? That seems like the thing that I would want, you know? Queue of strings. So what, images? Is that what you want? Yeah, input queue handle, reader head, read up does not match expected type of string. Alright, well, what about this? Are you expecting this type of string? String object has no attribute qref, of course. See, this is the kind of thing that I don't like. This, it's not proprietary, but this super custom reading of the data format. Like this is very obfuscated and frustrating to me. I just wanted to read in some numpy. And then have it, and if like we go through it in an intelligent way, that's super great. Like tf.train.startQrunners sesh equals sesh.session sesh-sesh sesh.graphdef and sesh.run. So is that where, is this thing? Is that where you're starting to load the data? tf.train? What does that mean? Helps train models. All right. What do you call it? Start queue runners. Starts all queue runners collected in a graph. Oh my goodness. Oh my goodness. Oh my goodness. Oh my goodness. Just wanted to read in the data. This is ridiculous. Yeah, I'm just gonna do the pickle thing here. That's just silly. That's absolutely silly. It should not be this complicated. I understand that they're doing this to be optimal and not destroy your machine with all the images that you want to read. But it is frustrating to me right now. Oh boy, oh boy, oh boy. Oop. There we go. We're not going to do that. We're going to import that at the top. Now we're just importing pickle because we're in Python 3 and we don't need no stinking C pickle. Unpickle file, which is a string. Really should not call that file. Don't want to collaborate with keywords. Not a good thing to do. Why don't I just, can I say pickle dot load s? Oh, does that load from a string? Read and return an object when given pickle data. Oh, no. I have used that before, however, that's not what you should do. Alright, that's fine. We're going to do this. We are also going to auto-indent. There we go. Okay, we're no longer using their silly formats. How was TensorFlow reading the data? How did it download? That's a good question. Read CIFAR10. Where's the download? Where is the download? Show me how you download. CIFAR10 dot maybe download. Yeah. Yeah, show me what you do there. Which one are you getting? Get them from Alex's website. Jeez, oh man. Data URL. That's cute. That's cute. Data URL, there we go. So he's got the binary versions, which is actually, I feel like I could use that. Given the appropriate binary version. Hey, against files in these batch, yada yada. Each of these files is formatted as follows. 1x label, 3072 times pixel. The first byte is the label of the first image, which is number range through time. Next 3072 bytes are this. First 1024 bytes are red, then green, then blue. That's actually not so shabby then. Each file contains 10,000 such whatever rows. Although there's nothing delimiting the rows, well yes, that's entirely understandable. Okay, we're just going to use this binary format. I don't even need this pickle. Forget the pickle. Pickle's out. We don't need pickle. Pickle is no more. Because we have numpy.frontFile. That's not going to work. Also, I need to import numpy. Numpy.fromFile. File. Is that to read an NP file? Yeah, text or binary file. Yes. So my data dir is, of course, /temp/CIFAR10 train. Yeah. There we go. I got a big glob here. Glob.glob of data dir plus. So this will grab all the .bin. Let's grab all our files. Let's import glob. So we can make sure to get that. Really? Am I misunderstanding something? I am misunderstanding. CIFAR 10 batches bin. Let me try that one more time. That should have worked. This is really list G. This is getting silly here. Whatever. Temp CIFAR-10 batches bin /star bin. These are a bunch of bins. Alright, I don't know why that's not, that's like the glob is the simplest thing. You can get, that's super duper weird. That doesn't make any sense. Glob.glob. Pass in a path. Turns a list of paths matching a path name pattern. Make a sane simple style like wildcards. Yeah, I bet it can. Let's do that. Nothing. What about locally? That's stuff. Because that's where I'm at. But like /temp is a place. /temp/CIFAR. I had CIFAR10 wrong, don't I? CIFAR10 data, not CIFAR10 train. Curse you. One of these days, man. So we did numpy.from file of g of 0, just for the sake of argument. How do we use this again? Whatever we're doing, then we say dtype equals numpy.uint8, I think. These are all bytes. There we go. Let's do that. Now what's A? A is a big honkin' long array. And it should be this long, right? Life is good. It's the correct length. Huzzah. Huzzah. Yes, so I need to just reshape that around. We want... let me see. Let me just start there. Labels are going to be every 3073, starting with the beginning. 3073. In fact, we have 10,000, which is, I believe, correct. 10,000 such whatevers. Yes, excellent. So images are actual data then. Is going to be a dot reshape. Oh gosh, how are we doing this? Into 10,000 things that are 3073 long. Let me just do that for the sake of argument. In fact, let me just do that up here. 10,000 3073. Perfect. And then this changes to just be give me everything in this column and the first. So if we do that instead and we do this, labels is the same thing, right? Excellent. And just to be paranoid, what's the maximum labels? 9. And the min in labels. So good. Those are actually our labels. We're making progress now. Images, however, is everything, comma, 1 to the end, dot reshape. We do still want 10,000, but now we want, what do I want, 3 channels? How do they store it? That's a good question. That's not at all clear here. How is it actually stored? How is it stored? Input. I'm not going to be distorting the images either. Oh, hey, next. If not a validata. Resized image, per image whitening, float image. There's all this strange image processing that I don't really need. Just want the image itself. And in fact, they're using basically the same thing. uint8 image, and they're making it float 32s, but whatever, that doesn't matter. Read CIFAR10 file name q. tf.string input producer file names. Which file names is just a list of all the images. So maybe that's really... Did I have CIFAR10.read? Of course, now I'm getting distracted. Dot read CIFAR10, and you can do this. Maybe not file names, but G. What does it say? A TensorFlow to models dot image dot whatever dot something dot a dot uint 8 image. Is this the actual image itself? No. And I just crashed my session again. All because I wanted to look at an image. This is not how complicated things should be. That's the third. Keep in count. 3 Python sessions I've had to crash. There might have been one extra that I chose to kill for whatever reason. All right, let's import some of this stuff again. Import numpy as np, of course. Slime example configure, not the last one used. Interesting that you won't even send to this. Alright, count of times I've had to kill that can also be incremented. That's super strange. It won't let me my Slimux is apparently broken now for reasons I can't fathom. Oh geez. Okay, we're gonna make a new window then. Kill out of that. I sincerely apologize for all the horrible problems that we're having. Again, the risk of doing things live. All because I wanted to read in some data. Dan indeed does data. Sometimes data wins. Oh yeah, now it shows up again. Yeah, whatever. Buddy. Okay. We're not ready to make our interactive session yet. This stuff is silly. That's silly. Here we go. Yeah, whatever. I'm gonna make it 3 channels of 32, 32, I believe. Let me look at the actual canonical. First 32 bytes of the red channel, we're only using the first row of the image. Yes, that's fine. Right. Because it does all the reds, all the greens, and all the blues. So let's see if we can do that. Huzzah, we can do that. Image is 0. Fantastic. Look at that. Look at that. Beautiful. Is there a good way to plot these? Let me just plot one of the channels, shall we? Import matplotlib as .pyplot as plot. Plot.ion. Plot.pcolor. Images 0 of the red channel, say. And of course, it's showing you the red channel in all these strange things, so it's not clear what's going on. Plot.cm. Is there like a red or something? Winter spectral. Oh boy. Colors. No. What are colors? Is that copper? Let's try that. Let's plot.cm.copper. I have no idea what this color map is like. Alright, it's a sepia tone kind of thing. I don't know what that is. Maybe the red channel is just not very interesting. The green channel, not so different. And the blue channel, also not that different. Okay, that's fine. If I import PI, yeah, no, that's fine, that's fine. We're not going to fiddle with that anymore. All right, now that we have our actual data, finally, That took 45 minutes to get the data. That's probably a new record. You know what? Let's try to do just some super duper, most basic thing possible. Just straight up logistic classification on all of these objects. So for this, I'm actually going to use straight up, let's see here, A of everything, 1 to the end. I'm going to use the unrolled images. And I also want my labels to be in the one-hot format. That'd be nice. TF dot. Oh, there's a way to do this. I just gotta look it up, as always. TensorFlow one-hot utility. There's no native op to do this, really. Like, it's not hard, it's just a pain that I have to do it. As of yada yada yada, as of a few days ago. Oh, and 0.7 release. Do training without needing to convert. Okay. Alright, we're gonna borrow their labels there. I'm gonna set paste before I do that, of course. There we go. Much better, much better. Look at that. So, labels hot equals dense to one hot labels. And in fact, there are 10 classes, so I don't even have to pass anything. Numpy is not defined. Oh, you're killing me. There we go. Redo that. Make that anew. Here we go. Okay. Assertion error because I already have a session. That's fine. That's just fine. Batch size 100, steps 100. That's all good. Images, labels, hot. Let's see how that goes. It doesn't like that. Alright, images unroll. Shapes. Tensor shape dimension none 10 and tensor shape dimension none 10 10 must have same rank. Interesting. Images unroll. Dot shape. And labels hot. 1010. So what went wrong here? It says n classes is 10. And here there's mnist.train.labels. Tell you what, just for the sake of argument, what does the mnist data look like there? mnist.train.labels. Oh, it doesn't have to be converted. Well, that's fantastic then. I'll just save myself the trouble. You don't need to put it in one hot format for this. Alright, here's it's going, it's cranking, it's doing something finally. So the evening is not a total wash. I don't recall how many epochs I said to do here. Fantastic. I'm sure, almost 100%, that this is going to be a terrible model, but that's okay. That doesn't matter at all. So I don't even, we're not scoring just yet here. Classifier dot get weights, right? That's a thing I can do. Get params or just weights. There we go. Classifier dot weights. So that's the weights for. There's 10 of these for each thing. Okay. Right, for each of the inputs, there's 10 classes. So let me not use that. skflow tutorial, yeah, that's what I want. This is where I screw around with matplotlib, which is what we're all about, really. That's for convolutions. I didn't even want something that complicated, you know? Is there a 2.5 somewhere? Alright, well, we'll just do this then. Yes, use the last one. No, don't use the last. God damn it. That's what I get. That is what I get. I just want to copy this. Because I want 2 rows, right? 5 things. Wasn't that complicated. Didn't need to get this complicated. Let's do this the easy way. W equals classifier dot weights. W, okay. W dot shape again. Right. I want W of all those and YY times what? Times the first one, times 2. So that's a particular class. I'm going to say dot reshape. You know what? Let's only get the first. Just show me the red channel, just for the sake of arguments. Yeah, 1024. There we go. Dot reshape 32, 32. Just to get a feeling of what the heck is going on when you do this. Watch this blow up in my face. I already know that actually did something. Okay. So you don't see any clear patterns, really, because we didn't train all that long. And again, we're just looking at the red channel there. All right, but let's see if in 5 minutes we can blitz through some kind of convolutional model, stealing a lot of code from our MNIST tutorial there. Namely, we're going to be stealing this Mac2 and this conv model code. That's really what it's all about. By stealing, well, this is borrowed from the skflow tutorial. Max pooling is, as it always was, convolutional model. Let's start with 32 by 32. Okay, we're reading in our thing X. We have 3 channels, however. Does that fiddle skflow.ops.conv2d in depth? Yeah, that's a tensor in. All right, so it's expecting a height, width, and a depth. So I really need to reshape this to be the other direction, which at the moment is just a little irritating. Right, images right now, this is a particular channel, so that's like the reds. But I need to line up all the reds at the same place. I can't just reshape it because they're literally in a different order. So unfortunately, we might not be getting to that tonight. Just the fiddling with the data took way too long today. It is possible I'm an idiot. If so, leave a comment telling me I'm an idiot, then subscribe. Tell me I'm an idiot. Tell me I'm an idiot on Twitter, And upvote me, but tell me I'm an idiot on Reddit too. That is entirely welcome. Images.reshape. I don't want to do that. There is a much smarter way to do this, I'm convinced. All right, I think that is the only thing that I'm gonna fiddle with too much today, I think, actually. That is a frustration, but that's just part of the business of being frustrated. Really though. List of ints, 1D of length 2. How do I tell it that does it just infer that there's this depth? I think it might just infer that. Which, hey, that's great. In fact, that must be the case, because in the second convolutional layer here, it's given 32 filters, 32 channels, but it just infers that. It doesn't need to worry about it. Now in this final layer, we'll have to sort out what's going on there. We might run into trouble. All these 7x7s I'll have to actually do correctly here. I'll just use hpool2 dot height and whatever to do that. Needs work. And need to read in data in n samples, height, width, and channels. So element a of say 0, 0, 0 is 3 RGB bytes, right? That's what we're gonna have to do. So maybe I'll get back to that for the next stream tonight. I'm just not gonna get to that, and that's okay. We started to read the data for CIFAR10. We wasted way too much time trying to understand how Google is doing that with TensorFlow. I mean, they've written a lot of code to like do it in automatically and sort of do it in, I'm sure, an intelligent way. It's just unclear what's obviously going on. And in a live setting, I can't sit here and read, well, what does this do? Then what does this do? Then what does this do? Then what does this do? Although it may look like that's what I'm doing anyway. So I think we are going to pause it there. We're going to call that good or bad, what have you. And I think that's going to be that. Next week I am off. There will be no stream. Go back and look at some of my old videos if you haven't before. Week after that we will be back. I haven't decided if I'm going to continue fiddling with this. That might be a good time to start a new project looking at Keras or something like that. So if you want to tell me how terrible I am or how awesome I am, how helpful it is, I really love to see those comments. Just drop me a line on the YouTube, on Twitter, send me an email. It's all very good.